Okay, hi everyone. So today we are going to enter chapter 5. So this video is for you to view at your own time, own pace, so that when you do your revision, in case there's something that you forgot what I said, you can always refer back to this video so that you are clear on the concept of what we need to do. Okay, so this chapter we're going to look at quadratic equations and quadratic graphs, and in 5.1 we're going to look in quadratic equations itself, how to solve a quadratic equation. But before we go there, right now, I just want to point out that previously we've dealt with expressions in chapter 3 and 4, right? So expressions are things like this, right? And the thing about quadratic is that quadratic, right, the highest power is going to be 2. Highest power of the variable huh? The highest power of the variable is going to be equals to 2. So what makes this a quadratic expression is where this is going to be 2, right? No, this highest power is going to be 2, this highest power is going to be 2, this higher power is going to be 2, this highest power is going to be 2. Okay, now so over here for expressions, right, what can we do with expressions? We can simplify, we can evaluate, we can expand, we can factorize, right? Now for equations on the other hand, they are much more than being a mathematical phrase. Now they become a full sentence. So it's x plus 1 equals to 0, full stop. So it becomes a full sentence. So when we have things like equation, we can do all of the above, but there is one special thing that we can do is to solve the equation, to find a value for x so that the equation satisfy both left hand side and right hand side, which means that the value of x is true for the left hand side and the right hand side. So it means if you put in the value of x into the left hand side, it's going to be equals to the right hand side of the equation when you put in the x. Okay, so with this, right, we will need to look into two things, right? So example over here is like, now we need to solve, instead of a linear equation, now we need to solve for a quadratic equation. So this one over here, let's observe how do we solve. Based on what we know last time, we will need to shift the x to either side of the equation, right, so that we can solve it. But for this question, let's say if we were to move we move 2 to the right, correct? But we cannot isolate a single x. We cannot solve for a single x. We only want our answer to be x equals to something, so that, but the problem is that we can't even rearrange it. We can't even get it to a single x. So what can we do instead is that the thing that we need, the thing that I advised you from last year, I spoke to you about last year, is that we cannot use methods from primary school and Sec 1 linear equations anymore. And this is why we are doing algebra, is to solve a more abstract problem like this. Okay, so in order to do this, we're going to make use of the following property. Okay, to solve for quadratic equations, we need this zero product property. So what is this zero product property talking about? It is, okay, so let's say if you have two numbers a and b equals to 0, then either a equals to 0 or b equals to 0. Okay, is this true? For example, if a is 5, so what must be the value of b such that this is 0? B must be equals to 0, correct? Right? So it's either one of them will be 0. Now, so over here, we will make use of this property so that we can solve a quadratic equation. Alright? Now, before we go on, have a little thing. Can it work for a times b equals to 5? Would it be a equals to 5 or b equals to 5? Would it be always the case? Actually, no. Right? Actually, a may be equals to 1, right? 1 times 5 is 5, 5 times 1. A can be equals to negative 1. A can be equals to negative 5. And the list goes on and on for the different variations for B, right? So actually, the short answer is actually no. Okay, so the short answer is no. It cannot work for A times B equals to 5, right? So over here, we need to take note that we need the equation to be 0 on one side, and then we can apply the zero product property. Okay, now let's quickly look at practice now 1. Alright, so practice now 1, we'll just jump right to question C and question D. Alright, so for question C, over here we have a 3x squared plus 18x equals to 0. Okay, so over here, what do we need to do first to make it to be a product, right? We need to observe that on the right hand side is already 0. So we can use the 0 product property like what is above over here. So we need to express this such that we have two factors and on the right hand side is going to be 0, right? So based on what I said just now, we need two factors. So what do we need to do over here is we need to factorize this equation, right? So factorize the expression on the left, right? So on the left hand side, what is the common factor that we can take out? We can take out a 3, we can take out an x, and then we have a x plus 6 over here equals to 0. Okay, so based on the 0 product property, okay, actually we can divide by 3 first, right? Let's divide by 3 to make life easier for us, right? So this one divided by 3 on the left would be just 1, 0 divided by 3 on the right would be just 0, right? Then based on the 0 product property, right, we can make it such that either this is 0 or this is 0 because these are already two factors. This is my A, this is my B, right? Correct? So this either A is 0 or it is either B is 0, right? So technically speaking, I would write down is either x is 0 or x plus 6 is going to be 0. Okay, so x is 0 is one of our solution. Then x equals to negative 6 would be the other solution that we're looking for, right? So when we solve for a quadratic equation, right, we have 0 and negative 6. Now, so one thing to observe is, let's say if you're solving for a linear equation where the power of x is 1, okay, so how many solutions will you get? How many solutions are you expecting to get? You're going to expect only one answer, one solution for the equation, right? But for a quadratic equation where the highest power is 2, right? How many solutions are we going to expect? We're going to expect up to 2 solutions. Okay, we're going to expect up to 2 solutions over here. Okay, so one more time, for a linear equation where the highest power is 1, so we have one solution only. Whereas for quadratic equation where the highest power is 2, right? So for power 2, we need to expect 2 solutions. So you can think already, right? For a power 3 equation, how many solutions do you expect? Right? It will be up to 3 solutions and so on. Okay, so without further ado, let's move on to part D. Right, part D, we have a negative 2 over 3x squared plus 5x equals to 0. Now, this denominator is annoying. So I'm going to multiply by 3 on both sides. So multiply by 3 on both sides will be negative 2x squared plus 15x equals to 0. Right? Times 3 times 3 times 3 throughout. Okay, then let's factorize. Let's take a common x out. So we have a negative 2x plus 15 is going to be equal to 0. So same thing. Now we have our two factors, x and negative 2x plus 15. So what we can do is x is equals to 0 or negative 2x plus 15 is going to be equals to 0. So x equals to 0 is our first solution. Negative 2x is equals to negative 15. So x is equals to 15 over 2. So this would be our second solution over here. Okay, so as expected, we have two possible solutions. So this is the end of practice now 1, and we're going to look at a slightly more complicated quadratic equation next. Okay, so let's jump right into practice now 2. And practice now 2, we're going to look at question 1, and we're going to solve for C, D, E, and F. Right, we're going to solve for equations C, D, E, and F. Right, for C, we have w squared plus 8w plus 16 equals to 0. Okay, so over here, what we need to do is, so because we cannot just move the 16 and we cannot just isolate one single w to solve. So then again, this is a quadratic equation, so we need to factorize. So we need to make use of factorization, right? So factorize the equation, the expression on the left. So how do we factorize? When we factorize this, Okay, so once you factorize this, it will look something like this, right? Using the box method, and you have like a w plus 4 and a w plus 4 is equals to 0. Okay, now for this factorization, just nice, the two factors are the same. So actually, we can just lump them together as w plus 4 square is going to be equals to 0. Okay, now then what else can we do is that we can unsquare this. So we square root on the left, square root on the right. So what do we get in the end would be just w plus 4 on the left, and square root of 0 will be still 0 on the right. So then w will be equals to negative 4. So what happens over here now? What happens is that this very interesting thing happens where we only have one solution instead of two solutions. Remember, I said that how many solutions can we expect? Up to two solutions. It's not exactly two solutions, but up to two solutions, right? So over here, what we see is there's only one solution. Why? Because over here, if you notice over here, this is actually a repeated factor. So this thing is already repeated. So meaning if it is repeated, we'll get back the same answer. Okay, we'll get back the same solution. Okay, so something like that. Now the alternative method to do this is you observe this. Okay, you observe this. So this is already in a nice one where we have a square plus 2ab plus b square. Now a square, so a is our w, correct? Let's double check. Now b is 4. So let's say 2ab, so it will be 2 4w. So just nice, it will be 8w back here, right? So it is in the form of a plus 2ab plus b square. So we can factorize this to a plus b square. We can just factorize to this, and then the whole process of factorization will be back over here. Okay, so this is the first question that we want to solve for the quadratic equation. Okay, alright, so for the part D, right, for part D, now we have 3 over 2 z squared minus 5z plus 4. Now this is not so friendly, so let's make it a friendlier version, right? So let us multiply by, okay, wait, hold on. Okay, so let us multiply this whole thing by 2 to get rid of the denominator 2, right? So I times 2 on the left, I times 2 on the right. So what do I get in the end would be, this one times 2 will be 3z squared. 5z times 2 is 10z. 4 times 2 is going to be 8. 0 times 2 is 0. Right? So we have something like this. So it's time to factorize using the box method. Okay, so using the box method, we can factorize like this above here. Alright, so after that, we can write this as the two factors. So 3z minus 4 and then z minus 2 equals to 0. So just nice, we have already factorized. This is a, this is b. So it's either the first one equals to 0 or the second one equals to 0. So we see it like this over here using the zero rule property. Okay, so then to solve this, so we just slowly move and slowly isolate our z. So z will be 4 over 3 and z is going to be equals to 2. So now again, there are two solutions over here. And the thing about this is, how do we check whether our solution is correct or wrong? So what we can do is we can take 4 over 3 and sub back here on the left hand side, and you can see that the left hand side in the end will be equals to the right hand side, right? Same if you were to take z equals to 2 and you sub it back here. So you put a 2 here, put a 2 here, you should be having this equals to 0 as well on the left hand side. Okay, so this is how we check that the solutions are correct. Okay, so the next question over here is 4h squared minus 20h plus 25. So same thing, using the factorization box, using the box method, we have something like this. Okay, so we have something like this, and then we have a 2h minus 5 and a 2h minus 5 over here. So this thing is going to be equals to 0, right? Because they are the same factor, they are identically the same, so I can put a square over here, right? They're the same, right? So I can put a square over here, and then I will just need to reverse everything, so unsquare, right? So unsquare means I need to square root on the left, square root on the right, right? And I have a 2h is equals to 5, h is equals to 5 over 2 as our final answer. So even though we don't get two solutions, we have at least one solution, right? So it will be up to two solutions. Okay, we're up to two solutions. Okay, so similarly, if you notice over here, this is a square, correct? So actually what you can do is you can factorize this using the identity a squared plus 2ab plus a squared minus 2ab plus b squared, right? And this will be equals to a minus b squared. You can use this to do the factorization like that. Okay, so last but not least, we have 3k squared plus 30k plus 48. So same thing, let's observe this is a quadratic equation. The highest power of k is 2, and then we'll need to probably factorize first. So before this, observe your 3, 30, and 48. Now, these are numbers that have a common factor of 3. So what we can do is, let us divide by 3 on the left. Let's also divide by 3 on the right. So on the left, when we divide by 3, it's going to be k squared plus 10k plus 16. On the right hand side, 0 divided by 3 is 0. Okay, so then let us factorize this. Okay, so you would be getting this as your factorized box method. And then over here, we have a k. We can write here k plus 2, k plus 8 as our factors. Okay, so now we factorize already. It will be either this first number or the second number equals to 0. So it will be k plus 2 equals to 0, k equals to negative 2. Or it will be k plus 8 equals to 0. So k will be equals to negative 8. So this is going to be our answer for part D. Oops, sorry, part F. Part F. This is F. Okay, let's quickly continue to question 2. So question 2 over here, part 1, we need to solve for the equation 3x squared minus 10x plus 8 equals to 0. So first, let's observe this is a quadratic equation. Highest power of x is 2, and on the right hand side is a 0. So very important, right hand side must be a 0. Now, so in order to solve for the equation, we need to factorize. Okay, so when we factorize using the box method, we get this box over here, and we can write our factors as x minus 2 and 3x minus 4 equals to 0, right? So it will be either this equals to 0 or that equals to 0, the two factors. So it will be either x minus 2 equals 0, so x will be equals to 2, or 3x minus 4 equals to 0, so 3x will be equals to 4, x will be equals to 4 over 3. So this would be our two solutions for this question, right? Now let's continue to focus on part B. Now for part B, what I want you to observe is, now this will be, we need to, hence means that the tip is to use the previous answer, right? The previous part or the previous answer, and to solve the equation 3 times y plus 1 squared minus 10 times y plus 1 plus 8. So it looks much more complicated than what we originally solved, correct? Now, so if we don't have a previous answer, so what we probably need to do is to expand the y plus 1 square, expand the 10 times y plus 1, expand the 3, and then we'll need to jumble up and to refactor and do all sorts of nonsense, correct? But there is a short way. Because we need to use the previous answer, so means that there may be a pattern for us to follow from the previous part. So you just observe, so this is 3x squared minus 10x plus 8. If you observe 3x squared minus 10x plus 8. So all the terms are actually corresponding to each other. They are same to each other. So technically speaking, we can make x to be equals to y plus 1. Okay, so over here, we let x to be equals to y plus 1, right? So based on the answer that we have previously, right? So x is equals to 2 or x is equals to 4 over 3. So we change x to y plus 1. We change x to y plus 1. So over here, y will be just equals to 1. And y over here will be equals to 1 over 3. Right? So over here we didn't need to re-expand and to solve a whole new equation. What we did is just to make use of x as y plus 1. We can represent x equals to y plus 1. So it's just a matter of pattern recognition. Okay, so last but not least for this video, for question 3, right? So for question 3 over here, now I'm going to put a short face over here. Okay, because this is a very important skill, alright, that we need to know. Now, so what are we saying here? Now, x equals to negative 2 is the solution of the equation for x squared plus px plus 8 equals to 0. Find the value of p. So if x equals to negative 2 is a solution, means we can substitute x equals to negative 2 into this equation. Right? Because it is a solution, we can substitute into the equation and it will be true for this value. It will stay the same for this value. The left hand side will still be equals to the right hand side. Okay, so part question 1, what we can do is to substitute x equals to negative 2 to the equation. Okay, because if it's a solution, it means that it's the answer to this quadratic equation. We can just substitute it into the equation, right? And it will still be the same. So over here we have an x squared plus px plus 8 equals to 0. So put in the negative 2 here. So you evaluate negative 2 squared will be 4. P times negative 2 would be a minus 2p plus 8 is equals to 0. So 4 minus 2p equals to 0. Let me do this slowly. So negative 2p is going to be equals to negative 4. When you divide by negative 4, so p is equals to 2. So this is the the answer to the first part. Alright, so part 2, hence, find the other solution of the equation. So the word hence means we need to use the previous answer. And what is our previous answer? P is equals to 2. So we need this x squared plus 2x plus 8 equals to 0, right? So how do we normally solve a quadratic equation again? We need to factorize. So let me try to factorize this now. Okay, apologies, I may have found an error over here. Alright, so the error is this. So 4 plus 8 is actually 12. This is negative 12, so p is equals to 6. So instead of 2x plus 8, this would be 6x plus 8. Alright, so let's factorize this later. Okay, so now I've done with the factorization. So now we have we have two factors, x plus 2 and x plus 4 equals to 0. So over here, x plus 2 equals to 0, or x plus 4 is equals to 0. So x will be equals to negative 2, x is equals to negative 4. So this one is already done. It's from the previous solution. X equals to negative 2, right? But x equals to negative 4 is the other one. This is the other solution. So if you want to restate it properly, so x equals to negative 4 is the other solution. Okay, so at this video, right, let us recap what happened in this video. In this video, we learned how to solve a quadratic equation. How do we solve a quadratic equation? We need to make use of the zero product principle. And based on the zero product principle, one side of the equation must be 0. And we can factorize our quadratic equation to two factors, and based on the two factor, it will be one of them equals to 0. So it's either a equals to 0 or b equals to 0. So it's either equals to 0. Then we can solve for x. And maximum, we have up to 2 solutions for x in a quadratic equation. So hope this helps, alright, with your revision, and stay tuned for the next videos to come.